Hello grade 12s, welcome to this lesson about application of Newton's laws. I believe you are working diligently and with determination wherever you are. Of course, this is an important year, it's an important grade, and you are definitely going to make the best. And before we start, just want to demonstrate here for us, this force called tension. Okay, so here's a string, okay? So consider my hands as two bodies, right? Or two blocks, block A, block B. So block A pulls that way, block B pulls in the opposite direction. So you create a stress in the rope. So tension is a stress force, okay? So just look at this. A is pulling B, right, in that direction. And B is pulling A in that direction. So your vectors must be like that when you do your free body diagrams or even your calculations. One must be a plus, one must be a negative. All right, so that you take care of the meaning of that, because it is also supported by Newton's third law. Okay, it's an action-reaction pair. All right, remember tension is the same throughout the rope, is consistent. Sorry, it's constant. Okay, so it will be the same, but just in opposite direction, depending on whether you're talking about this block or that block. All right, so they will be like that. Good stuff. So we can start. The entire question is not here. I'm going to read it because it's lengthy. It's not going to fit here and with my solutions that I'm going to present. So I just wrote down for us the questions based on the scenario. So I'm going to read the scenario for us. That is the supporting diagram. So it says A and B below are two identical blocks, each with a mass of 5 kgs, joined together by a light inextensible string. The blocks are being pulled with a force of 65 newtons at an angle of 40 degrees to the horizontal. The two blocks accelerate to the right at an acceleration of 2.17 meters per second squared, and the tension in the rope is 26 newtons. Okay, information, let's look at this. You can confirm it. It is exactly as the scenario has said in words depicted here in the diagram. Okay, so there are two questions that we need to answer here, and to answer them successfully, we need to understand what's going on. Here are two blocks, A and B, connected by a string, and I just spoke about tension, meaning the tension here is 26 newtons, right? That is throughout the string itself. The mass of the two blocks is 5 kg. We are told that they're identical blocks. Okay, what is happening here? Right here, there's a force acting on block B of 65 newtons, at 40 degrees relative to the horizontal. Okay, so that is the diagram itself. And the very first question is calculate the friction on each block. Okay, we're not asked to draw free body diagrams, but we understand that by now, and at this level of physical sciences, those are crucial mediums to get to the solution of an answer. As part of the inquiry, we investigate what are the forces. They are not seen, we can see them, but we need to highlight and bring them out to our awareness. So we can simply do a rough sketch. Okay, for block A, we know that there will be weight. Obviously, again, normal force, it's a horizontal surface, and there will be tension, and this T is given as 26 newtons. Okay, what is the direction of motion? The scenario says the system or the two blocks accelerate to the right. Okay, so looking at the diagram, the right, so the direction of motion is to the right. Okay, so we get that in our scenario, meaning that as per definition, friction is the force that opposes motion. Friction will be in the opposite direction like that. Okay, we're done with A. Let's go to B. Again, weight and normal force. Okay, and what do we have here? With friction again, and then we'll have tension here. Okay, remember, one is to the right, the other tension force is to the left, but the magnitude is the same, Newton's third law. Okay, and then what is happening again? We have this force acting at 40 degrees, so we can include it here. So we have the 65 newtons relative to the horizontal at 40 degrees. We understand by now that there will definitely be components, your x and y components. All right, so a frame of reference here for our calculations. I always use the Cartesian plane. I think you know by now. You know, forces going to the right are positive, left is negative. Forces going down are negative, forces going up are positive. All right. So this is the diagram that we have, and we can include, so that you don't forget, the components, right? So this is Fx, all right, or F applied x, and this will be F applied y, okay? And they obviously make a 90-degree angle. So what do we need when we talk about the friction on each block? So the friction and the tension are the two forces that are contributing to the net force acting on this block here, block A. Okay, so for A, we have the net force is equal to MA. Why are we using this equation? Obviously, we are applying the laws of Mr. Isaac Newton, and we understand that the net force is the sum of all vectors acting on a mass or on a block or on a body, all right? And with some vectors, obviously, according to their direction or their dimension in which they exist, all right? So that's the net force. What are the forces that are contributing to the net force on the block here, block A? There are two of them, all right? One is to the right is positive, one is to the left is negative. So we have the tension minus the frictional force is equal to the mass. It's 5. What is the acceleration? Acceleration is in the direction of motion and it's positive. So it is positive 2,17. All right. So what do we have here? The tension is 26. So we just have that. And yeah, we will have to obviously calculate, transpose 26 minus that. Please do it with me. Trust that you are also participating, working with me, calculating, this, so that you confirm that what you see is indeed true. Okay, so when you do the calculation, I get that the frictional force for block A will be 15.15 newtons. That's the magnitude of the frictional force for A. Let's do it for B. What will be the forces that are contributing to the net force acting on B? Again, the direction of motion is horizontal. It's not vertical. So we take horizontal forces like we did here. But how many horizontal forces here? 3. The frictional force, the tension, and the x component of the applied force. Okay, so we understand that your F net is equal to MA. Your applied force is in the positive direction by choice of direction there. Okay, you minus the tension, you minus the friction, and the mass is still 5, and the acceleration is the same. Remember, this is a system, so it moves together, and therefore the acceleration is the same for both. Okay, the applied force, we can get it, the x component here, because we're given the magnitude is 65 and the angle there. So by using trigonometry, we have 65. Okay, cos of 40 degrees. The tension is the same, but the negative takes care of that for us in terms of what I just demonstrated in the beginning of this lesson. It's a minus 26, right, newtons, and then we're looking for the friction. Okay, and that side we'll need to calculate as well. It's gonna be what, 10,34. But let's do the entire calculation in our calculators so that we can confirm that we have the same thing. Sorry, it's 10,85. All right, do you see why we need, to confirm and work together? All right, 65 cos 40 minus 26 minus 10,85. 65 cos 40, and then it's 36 and then minus 10,85. Good. I get 12,94. Okay, so therefore friction here is 12,94 newtons. Okay, so I trust that that is the answer that you also got. All right, what do we notice? For the two identical blocks with the same mass on the same surface, the friction experienced by both blocks differ. And with the follow-up question, this is a clear giveaway. It says, explain why the frictional forces on the two blocks differ. Okay, so it tells you that your answers must be different from the previous question. You don't want to force them to be the same because of, having the same mass. The science and the mathematics will take care of that. So now you need to reason as to why would there be a difference now in terms of the frictional forces? What is happening? What affects the frictional force? We understand that mu k, we need to reason by this, coefficient is constant for each surface, or you can say for a specific surface, whether it's wood, whether it's ceramic, whether it's plastic, so each surface will have its own coefficient of friction. Okay, so let me just add it here. Coefficient of kinetic friction is unique or is constant for a specific surface. But how do we relate the coefficient to the frictional force? There's an equation that helps us, and the equation looks like this. It's mu k times the normal force. Now we need to bring in this vector and talk about it. What is different here? Okay, because this is the same for both blocks. Now this vector must come in and we use it to reason in terms of the solution or the answer to that question. What would be the normal force for block A? For A, the normal force will just be mg. Okay, what is the mass? The mass is 5 kg times 9,8. Okay, let's press the buttons. 5 times 9,8 is 49. Okay, so this will be 49 newtons for block B. Now let's be careful here, right? Normal force cannot be equal to the weight because there's a y component here that will reduce the normal force. How? There are two forces that are going up by choice of direction. They'll be in the positive direction. So the normal force plus the y component of the applied force, they will be at equilibrium with the weight, or they are the equivalent to the weight. So therefore, we are saying that the sum of these two forces will give us the weight. Okay, so if we want the normal force for block B, which we'll use to get the frictional force for block B, we have that its weight minus the applied force, the y component of the applied force. And what is this? The weight will be 5 times 9,8, it's 49, minus 65 sine of which angle? 40 degrees. So you understand that we are reducing the size of the normal force. From 49 we minus a particular value, and obviously it will be less than 49. Okay, so the third factor, the second reason is that n decreases. Okay, First one is that, talk about coefficient of kinetic friction. The second thing to talk about is that, and your calculation clearly supports what you're saying here. You see, N decreases from block A to B because of what? There's an applied force here at block B. It has nothing to do with A. This force is acting on block B. Okay, so N will decrease from A to B because of the presence of that applied force, and we have to accommodate the Y component. And the third reason will be because normal force is directly proportional to, the kinetic friction. If you decrease the normal force, you decrease the kinetic friction acting on that body. Okay, it has nothing to do with the coefficient of kinetic friction unless, it was different surfaces altogether, for the different blocks. But this is the reason that we, conclude by, when we answer such a question, coefficient of kinetic friction, the calculations are there to support our reasoning. Therefore, block B, the normal force is less than the block A normal force, and therefore, because of the proportionality as well, direct proportionality between the two quantities, if you decrease normal force, will decrease the kinetic friction. All right. So, grade 12s, this will be it for this lesson. I believe you've enjoyed it. I believe you've learned a lot, and you are able to see how one question and its solution will affect, the follow-up questions. So thank you for tuning in. Remember to subscribe. Remember to share the video with your friends, with your classmates, and your schoolmates. And yeah, thank you for tuning in. See you next time. Sharp, sharp.